Okay, so I'm going to get this day's notes started. Sorry I couldn't be there in person, but it's nice that I'm able to at least get the notes to you all this way. So I'm going to annotate this PDF file like I would be doing in class. I'll also upload it for you all, and then you also have the other videos for voting theory that you can refer to on the same topics, but I figured I'd upload a video with our own discussion as well. So one thing I want to point out before I get started with new material is to just remind you of two things that we talked about last week. So we talked about what a Condorcet candidate is. Again, someone who defeats every opponent in head-to-head competition, which is a way to tell who the winner of the method of pairwise comparisons is. But one confusion that there was in the homework that I just want to make sure is clear before we get started is that the fairness criterion, the Condorcet criterion, can apply to any voting method, not just the method of pairwise comparisons. Similarly, a Condorcet candidate can appear in any election, not necessarily one where we're using the method of pairwise comparisons. So for any fairness criterion, not just the Condorcet criterion, any of them, they can apply to any of the four voting methods that we've talked about. So the Condorcet criterion can be applied to the plurality method. The Condorcet criterion can be applied to the instant runoff voting method. It can be applied to border count, and it can be applied to the method of pairwise comparisons. So again, any of the four fairness criterion, we're going to talk about the last two right now, can be applied to any of our four voting methods. Alright, so hopefully that's just a little bit more clear after the homework that you all had over the weekend. So the last two fairness criterion have something in common, which is why we usually save them for last, but also teach them together, because they both deal with a revote needing to occur. So special circumstances that may lead us to have a revote in an election. So think about what might cause a revote in an election, where you need to recount or actually have the voters redo their ballots, to recast their ballots. And it could be a number of reasons, but think of what those might be. So the first fairness criterion that has to do with a revote is called the monotonicity criterion. And the word monotonicity, if you think of the word monotone, it just means that, you know, it's sort of the same tone, right? It doesn't change. Similar kind of thinking with the monotonicity criterion, in the sense that you have an election, you pick a winner using any of the four voting methods. For some reason there needs to be a revote. Again, many reasons can cause that to happen, but suppose that a revote needs to happen in an election after you've already picked the winner. And in the revote, some of those voters are going to change their votes to move the winner of the original election higher on their ballots. So for example, suppose that candidate A wins in the original election, then there's a revote, and voters who maybe didn't have A in first place now decide to move A up on their ballots and put A in first place. As long as no other changes are made where any other candidate is moved higher, what the monotonicity criterion is saying should happen is that the same person should win no matter what. If the voters change their votes to favor the original winner of the election, that winner should still be the winner even after the revote. So when you're checking to see for fairness with this criterion, you need to redo the voting method after the voters change their ballots, because you want to double check, does the same person win again? And if they do, everything's great. But if somebody else ends up winning the election, even with the voters changing their ballots to favor just the original winner, that's a violation of the monotonicity criterion. So as always, we're going to do an example just to double check to see if we understand what the criterion is saying. Now again, the criterion can apply to any of our four voting methods, so I could be using plurality to find the winner, I could be using instant runoff, border count, or method of pairwise comparisons. In this example, we're going to use instant runoff. So we have three candidates, Anne, Bob, and Claire, A, B, and C for short. The results are as follows. Okay, the first thing you want to do is probably check how many people won. Not how many people won, how many people voted in this election. So I believe this is 29. We just want to double check. 8, 7, 10, and 4 adds up to 29. And remember that in instant runoff, you're choosing the majority candidate right off the bat. So majority candidate needs to have over half of 29 of the votes, which would be 15 or more first choice votes. A has 11, C has 10, and B has 8, and therefore nobody has majority. So remember that in instant runoff, we're now going to conduct a runoff. We're going to eliminate the candidate with the least first choice votes, which is going to be candidate B. And it turns out that that's going to favor candidate C, because now these 8 ballots are going to count in C's favor after eliminating candidate B. So this means that C will now have 18 first choice votes, and that's enough to be the winner under instant runoff. So candidate C wins under instant runoff. They didn't win right away because nobody had majority right away, but they end up with majority after eliminating the person with the least first choice votes. Okay, so in order to check to see if this result is fair, and fair according to monotonicity criterion, there would need to be a revote in which some of these voters, either these 7, these 8, or maybe these 10, or maybe these 4, change their ballots in a way that favors candidate C. So actually in that case, these 10 people would not change their ballots. They already have candidate C in first. So it's either going to be the voters in the first column, those 7 voters might change and rank C first and push everybody else down. Maybe the 8 voters in the second column might push C up to first and move B into second and A in third, and so on. So let's see what's going to happen in the revote. Okay, so suppose, for some reason there's a revote, and the following preference table is the new one. So focus on this preference table now. This is the new one. So let's see what happened. How is this preference table in purple different than the preference table right above it? And you might be noticing these 4 people decided to change the way they voted. So initially they voted with A in first, C in second, B in third. But they decided, you know what, we like candidate C better, so in the revote, they move C up to first, A gets moved down to second, and B remains in third. So this is an example of there being a revote where the voters change their ballots from how they originally voted to a new way that favors the original winner of the election. Now remember that under instant runoff, we said C wins. So here's an example where C is being favored by the revote, by these 4 people changing their ballots. Let's see if C wins under instant runoff. Now remember, in instant runoff, somebody needs to have a majority. We said that's 15 or more votes. C has 14. B still has 8, and A now has 7. So who's going to get eliminated? Candidate A. And what do you notice is going to happen after the first round of instant runoff where candidate A gets eliminated? What's going to end up happening, and a not very good result, is that these 7 votes will now go to candidate B, and together with the 8 first choice votes they already had, candidate B ends up winning in IRV in the revote. So this is definitely an example of the monotonicity criterion being violated. We satisfied the first condition, that there needed to be a revote in which the original winner gets favored when some of the voters decide to change their ballots. We said that in those 4 that are circled in blue, candidate C was the original winner. Candidate C is favored by the ballot switches. But despite that, that's not enough to give them the win under instant runoff. We eliminated candidate A. That gave B an additional 7 votes, and that gave B the majority. And so this is a violation of the monotonicity criterion. Now, I'm going to zoom back to the monotonicity criterion for a second, because remember, the way that the monotonicity criterion is stated, there's a few things that need to happen. And so, an election needs to be held. I'm just going to number it. An election needs to be held where you declare a winner. Again, it could be under instant runoff, it could be under board account, method of pairwise comparisons, or plurality, any of those 4. Second thing that needs to happen is that a revote is held. So unless there's a revote, you can't even check to see if there's a violation of this criterion. There needs to be a revote. And then what happens in the revote is that some of the voters change their ballots, change their votes to move the winner of the election originally higher on their ballots. Then you redo the voting method, same one you used the first time to figure out who the winner was, and you expect that the original winner should remain the winner in the revote. And if they don't, like we just saw in our example, that's a violation of the monotonicity criterion. Okay. We just did this example. So what conclusion follows about the instant runoff voting method and the monotonicity criterion? Well, we just found an example where there was a violation. Does this mean that it's always going to happen? Not necessarily. But once you found one example of where it happens, you can say the following, that the instant runoff voting method will sometimes violate the monotonicity criterion. Again, not always, but we found an example where it did, and so therefore it will sometimes violate the monotonicity criterion. So it may seem like a surprising result, again, because how is it possible that the voters change their ballots to favor the original winner? Why wouldn't the original winner stay the winner? But it can happen. Again, this can be with any of the 4 voting methods, so depending on what your voting method does, like board account gives points, method of pairwise comparisons checks those head-to-head competitions, and we just saw what happens with instant runoff, it happens, right? Sometimes violation can occur. Now, such violations are rare, so it's not saying that this is always going to happen or happen often, but it can happen, so it's something to look out for. But always, always, always make sure that if you're going to apply the monotonicity criterion to a voting result to check to see if it's fair, there needs to be a revote. Okay, the same is going to be true for our last fairness criterion. Our last fairness criterion is the IIA, for short, because it's a mouthful, the independence of irrelevant alternatives criterion. And so from the title, irrelevant alternatives would be candidates in an election that, don't really have a chance to win in the first place, and therefore if they are removed from the election in a revote, either because they drop out or because they get disqualified, it shouldn't make a difference to the results of the revote. So both of the fairness criterion, I'm just going to highlight that for a second, both fairness criterion involve a revote, but just keep in mind that it's what happens in the revote that helps you make the difference between whether it's monotonicity criterion or the IIA criterion. So in the monotonicity criterion that we just covered, we said it was the voters changing their ballots. In the independence of the relevant alternatives criterion, it's the candidates who are making a switch. And not really a switch necessarily, but they're changing what happens in the revote, either because they are going to drop out of the race, or because they're going to be disqualified, or some other reason for removing themselves from the race. So it's not the voters that are making the change in IIA, it's the candidates. So again, just the text of that fairness criterion. Suppose that an election is held using a specific voting method, and again, this can apply to any of our 4, and you pick a winner. So, I don't know, we could be using plurality, let's say. Then there's a revote in which a non-winning choice is removed from the ballot. So whoever won the original election cannot remove themselves from the ballot. If they do, then that's not an application of the IIA criterion, that's just something else happening, right? So in the revote, it's a non-winning choice that's removed from the ballot. That's the second thing that happens. Then we expect that since a non-winner, an irrelevant alternative dropped out, that the original winner should remain the winner in the revote. I mean, it makes sense, right? Like, why would somebody else win if you have a winner, a non-winning candidate drops out, the original person should still win. Okay, so keep in mind what's the difference between monotonicity and IIA. They sound very similar because they both involve revotes, but they are not the same. So keep in mind what the difference is between these two. I have the difference highlighted on the next page, but you want to make sure that you understand what the differences are as well. So in monotonicity, some ballots have changed, so the voters caused the change in monotonicity. For IIA, it's a change with the list of candidates. So it's the candidates that are making a change in the revote, either by disqualification or by removing themselves from the race, or for some other reason they're not part of the revote. Now remember, it's a non-winner that has to drop out or get disqualified. It can't be the original winner of the election, or else that's not an application of the IIA criterion. Okay? Just keep that in mind. So now, again, the IIA criterion can apply to any of our 4 voting methods, but we're going to practice the method of pairwise comparison since we just talked about that last week. So we're going to do that. Here is an election where 8 people voted. So again, this is where the 8 is coming from. 2 plus 2 plus 2 plus 1 plus 1. 8 people voted to decide between Anne, Bob, Claire, and Dave who will win the award for Best Stand-Up Comedian at Rutgers. So it's 4 candidates. They perform. The committee of 8 cast their ballots, and this is how they voted. So we are going to check every single head-to-head competition to see who the winner is under method of pairwise comparisons. Now remember that you give points to whoever wins a head-to-head competition. So in A versus B, A is ranked higher than B 2, 4, 5 times. That's 5 out of 8. So the B is only ranked highest 3. Okay. In A versus C, A is ranked higher than C 2, 4, 5 times. Also 5 out of 3. So far A wins. I'm just going to circle that in a different color. A wins this head-to-head competition. A wins this head-to-head competition. If A wins the next head-to-head competition, they are our Condorcet candidate. But let's just double check. So A versus D. A is ranked higher than D. Here. And here, I believe that's it. So it's only 3 times. Let's just double check. A versus D. Yep, that's 3 versus 5. Oops, so then that's not going to be the Condorcet candidate because D wins that head-to-head competition. Okay, so A has 2 points so far, right? They win the first 2 head-to-head competitions that they're in, but they lose the next one. So D gets a point for that one. Let's check B versus C. So B is ranked higher than C 2, 4, 5 times. That's 5 out of 3. B wins. Be thinking about why B cannot be the Condorcet candidate even if they win these 2 matchups, right? Why can't they be the Condorcet candidates? We're going to check B versus D now while you're thinking about that. So B versus D. 2 times higher. 3, 4. Oops. Not oops. This is going to be a tie. So B versus D, they get half a point each. All right. Now, looks like we don't have any Condorcet candidate, but that's okay. We can still find out who wins under method of pairwise comparison. It's just going to be the person with the most points. So C versus D, this is going to be 2, 4, 5 versus 3 again. C wins. All right, so let's tally up the points. Just going to scroll up a little bit so we can see that. A is going to have 2 points. B has 1.5 points. They were in a tie. C has just 1 point, and D has 1.5. Yep, D has 1.5 points because D was also involved in a tie. So the winner in the method of pairwise comparisons is not always the Condorcet candidate. Obviously, if they are the Condorcet candidate, they automatically win, but in this case, the winner is A, because they have the most points based on their head-to-head competitions. Okay, so this is the results of the original election. We use the method of pairwise comparisons, we check to see who won, candidate A is the winner. In order to check to see if there's a violation of the IIA criterion, who is eligible to drop out or remove themselves or be disqualified, I guess, from the race, it would have to be anyone other than A, so a non-winner. It could be candidate B dropping out, C, or D. Okay? So suppose that C, or Claire, is disqualified. So she wasn't a Russer student, she wasn't eligible to be part of the competition, so candidate C is eliminated. She is disqualified, so I'm going to cross her out here, but I'm also going to rewrite the ballots just to see it a little bit better. So C being disqualified converts these ballots to BAD, DAB, DAB again, BDA, and ABD. I'm just writing the ballots from above without candidate C. Again, C was disqualified, right? So in order to check to see if this is a violation of the IIA criterion, so far it's not because a non-winner dropped out. So what we want to do is use the method of pairwise comparisons again, but with this new preference table to see who wins. Is it still candidate A who's going to win in the revote? So thankfully there's less head-to-head competitions that we need to check. It's A versus B, A versus D, and B versus D. Okay, so I'm going to circle these in a different color now so we can keep track. So A versus B. Okay, ranked higher on 2, 4, 5 ballots. That's 5 versus 3. A wins. That's 1 point. Now we're going to check A versus D. 2, 3 versus 5. Okay, so we're going to give D the win there, 1 point. Oh, that's already telling us that A, actually, let's check B versus D. Let's not make any conclusions yet. B versus D. Okay, 2 times ranked higher, 3 times ranked higher, 4 times ranked higher. So that's 4 versus 4. That's a tie. So let's tally up the points then. Just going to erase that. If we tally up the points, I'm just going to write next to each of these half a point, half a point. Remember, a tie gives you half a point each. A has a total of 1 point, B has half a point, and D has 1.5 points. So notice that the winner of the revote of the new election is not the original winner. Remember, the original winner was candidate A, and all of a sudden, after C was eliminated, a non-winner was eliminated, somebody else ends up winning the election. I wonder why that happened. I guess we would have to go back and check the original table and see why that happened. Let's see if we can scroll up really quick. So C being eliminated, why did that not give A the advantage? What do you think? So C being eliminated, why didn't that help A out? That's interesting, because I guess you could say that C being eliminated on these 2 ballots gives D an extra 2 votes where they're ranked higher, maybe. But also maybe here, C being eliminated, A is still at the bottom, so they're not going to be ranked higher than B or D on this ballot. It's only 1 ballot, but maybe 1 ballot could have made the difference. So, there could be a few reasons why that's happening, but clearly under the method of pairwise comparisons, the IIA criterion has been violated. So what conclusion would we draw about the method of pairwise comparisons and the IIA criterion? Well, That's going to tell us that the method of pairwise comparisons will sometimes violate the IIA criterion. Doesn't mean it's always going to happen, but we found an example where it does, and therefore we will have to say that it sometimes violates. Okay, so it did in this case. You can say that it will sometimes violate. Okay. So that brings us to the last question of this chapter, and the question is there a voting method which would never violate any of the fairness criterion? So out of all of our fairness criterion, we have majority, Condorcet, monotonicity, and IIA. Again, remembering that these two involve a revote, the other two do not necessarily. Is there ever a voting method that will never violate any of these four fairness criterion? So it turns out that there isn't. And so that is what the last sort of statement in this chapter kind of gives us the understanding of, is that for every voting method, you know, and in this class we've discussed 4 of them, so for every 4 of the 4 voting methods we've talked about, plurality, instant runoff, boarded count, method of pairwise comparisons, there is at least one fairness criterion of the 4 we've talked about, the 4 that we just wrote above, which the voting method sometimes violates. Again, it's not always going to happen, but you can find an example of it possibly happening. So there's no perfect voting method. There's no voting method that will never violate any of the 4 fairness criterion. Each of them may produce at least one fairness criterion violation. Okay? So it's important to understand that this doesn't imply that democracy is unfair. It just means that every voting method is vulnerable to some kind of unfair outcome. Now remember, unfair and fairness, if you could see me with my air quotes, that, you know, fair to who? Like, I mean, we do have to have some kind of standard for how we're measuring fairness, and that's what the fairness criterion helps us to do, is that we measure our 4 voting methods against these 4 fairness criterion, and we see that sometimes there's violations. It doesn't happen with all of them, it doesn't happen all the time, but it sometimes happens, and so no voting method is perfect. So that brings us to the end of voting theory. We're going to start a new chapter by Thursday. I hope to be there in person on Thursday, but we'll definitely be starting a new chapter Thursday. But the homework for this week will have you just finishing out some ideas on voting theory. There were some questions I couldn't ask you last week on the assignment that was due by Sunday because we still hadn't talked about these last 2 fairness criterion. But one thing I want to leave clear again, just at the end here, is to remind you that any of the 4 fairness criterion can be applied to any of the 4 voting methods. The same thing with finding a majority candidate and finding a Condorcet candidate. You can do that for any election. It doesn't necessarily tie itself to a voting method. In other words, a majority candidate can be found in any election, not just when you're using instant runoff. A Condorcet candidate can be found in any election, not just when you're using a method of pairwise comparisons. So write yourselves those notes. Those are really important ideas to keep in mind. Okay, so I'm just going to post this video for you all, but remember you have some other videos that you can watch as well if you find it helpful.